morning, students. Okay, so in yesterday's class we had stopped with the exercise number 2D. So today we will continue with it, exercise 2D, the third question. Okay, the question is same, expand the brackets and simplify. But the sums which are given to us would be a little lengthy and little difficult. Okay, so let's see the first sub question which is there. So it is x multiplied by x square minus 1 plus x square multiplied by x plus 2 minus x multiplied by 5 minus x square. Okay. So as I told you, what do we do to expand the brackets? We multiply whatever is there outside the bracket, we multiply it to each term inside the bracket. Okay. So here with the first bracket, this is the first bracket. So in that this x has to be multiplied with this x square as well as this minus 1. So I write x multiplied by x square minus, this minus is the minus sign which is there here inside the bracket. Okay, then x multiplied by 1. Okay, and this was all about the first bracket, so I put a bracket here because this was about the first expression. Okay, now we go to the second expression. This plus sign I write as it is. Then I have to multiply this x square to each term which is there inside the bracket. So I multiply x square to this x plus x square multiplied by 2. Okay. This is about the second expression. Now I go to the third expression. I write it here down, minus this minus sign. Then here I have to multiply x to 5 also and to minus x square also. So x multiplied by 5 minus x multiplied by x square, and this is also inside a bracket. See, for every expression I have put a bracket here because if there is a plus sign it doesn't make any difference, but if there is a minus sign outside the bracket then it makes a difference. Okay, then if there is a minus sign, the sign of each term changes. That is why you need to put a bracket. If you don't put this bracket, then you will get confused and your signs will go wrong. Okay, this minus sign here, this term will have a minus sign, but this, when you multiply this minus sign inside, this term will become positive because this minus and this minus will become positive. That is why if you don't put a bracket, you will get confused between the signs. So that is why before solving you put a bracket there. Okay, so now that means this minus sign which is there outside, I have kept it outside only. In the next step I will multiply it with the inside terms. Okay, and this I have written this multiplication inside the bracket. Okay, now I solve each bracket. Now this is x multiplied by x square. The bases are same and they are multiplied. So by first law of indices I add their indices. So it becomes x raised to 1 plus 2 is 3. Okay, then minus x into 1 is x. So I write x here. Plus the second bracket, x square multiplied by x, similar to this. Both bases are same and they are multiplied. So we add their indices. 2 plus 1 is 3. Plus 2 multiplied by x square is 2x square. Okay. Then we go to the third bracket. 5 multiplied by x is 5x. Minus x into x square. Similar to this. Bases are same and they are multiplied. So we add their indices. 1 plus 2 is 3. Okay. So these are the three brackets which I have got. Now I have to open these brackets. Open means I have to cancel these brackets. I don't want brackets anymore. So what do? I have to multiply it with the sign which is there outside. So if it is plus, the signs will not change. But if it is minus, then the signs change. We will see. Okay. So this first bracket will remain as it is because there is no number which has to be multiplied, or there is no minus sign outside it. So x cube minus x will remain same. Then the second also, it is having a plus sign. So plus into this plus will remain plus only. So plus x cube. Then this plus multiplied by this plus. Plus into plus is plus only. So again I write plus. And then the second term 2x square. Okay. Now for the third bracket, there is a negative sign which is there outside. So I have to multiply this negative sign to each term inside. So minus into 5x is, this sign outside is minus, and 5, the sign of the number 5x is positive. So minus into plus is minus. So I write minus 5x. And for the next term, this term is having a negative sign in front of it, and outside the bracket also there is negative. So this minus multiplied by this minus becomes plus. Minus into minus is plus according to the multiplication sign rule table, right? So minus into minus is plus. So this becomes plus x cube. Okay. So we have got this now. Now in this, you can see that here there are like terms also. So I underline the like terms. So there's 1x cube term, second plus x cube plus x cube. So there are 3 x cube terms. Then x terms, there are 2, minus x and minus 5x. And x square term, there is only one term. So we have no similar or like term for x square. So I keep it as it is. Now I bring the x cube terms and the x terms together. So x cube, this the first x cube, then plus the second x cube, plus the third x cube. So I have written all the 3 x cube terms together. Then I write the x terms together. The first x term is minus x. So I write minus x. Then the second is minus 5x. Okay. And then I write the x square term which is left. 2x square. Okay. Now I have to add these like terms. So these 3 are like and these 2 are like. So x cube plus x cube plus x cube. These 3 are similar terms, like terms, and their coefficient is 1, 1, 1. There is no number in front of it, means there is 1. Right? Each term is having a 1 here. So 1 plus 1 plus 1 is 3. So 1x cube plus 1x cube plus 1x cube is 3x cube. So this becomes 3x cube. Then minus x minus 5x. So how do we solve this? Two numbers are having negative sign. So what do we do? If both the numbers are negative, then we add them, right? So this coefficient is 5 and this is minus 1. If there is no number, then it is 1. So we add 5 and 1. So what is 5 plus 1? 6. And this x which is carried with it. So 6x. And which is the greater number? 5. 5 is having a negative sign. So I put a negative sign with this. So this is 3x cube minus 6x plus 2x square. Okay. So I've got this expression. So this, we cannot simplify this expression further. So we keep it as it is. Or as I said, we can arrange it in order. 3x cube. Cube is the largest power. Then I write the 2x square power. Then I write 6x. Okay. You can keep it like this also, or you may further change the order and write it like this. So both are the same. So this is the final answer of this expression, expanding this expression. Okay. This is very simple, but only you need to consider the negative signs. You need to check whether it is negative, where to put a bracket. If you put brackets, your solving becomes easy and there is no confusion. Then you don't get confused in the negative signs and all your signs are correct. Okay. So this was the first one. Now we go to the second question. The second question is, this is the first bracket, this is the second, and this is the third one. So now I have to multiply, for the first bracket I have to multiply this m to all the terms. So I write m multiplied by 2 plus m multiplied by n. Okay. This was the first expression. Now I go to the second expression. In the second expression I have to multiply this n to each term. So I write n multiplied by m minus n multiplied by 3. Okay. So this was the second expression. Now for the third expression, before the third expression there is a negative sign. So I put a negative sign and there is nothing to be multiplied with the third bracket. So I keep it as it is. mn minus m. Okay. So these were the 3 expressions which we have. Now I multiply each term. So I get m into 2 is 2m plus m into n is mn. Then n into m is mn minus 3 into n is 3n minus mn minus n m would be as it is. Okay. Now I have to remove these brackets. So to remove these brackets, I will have to multiply the sign which is outside. Okay. To remove these brackets, I have to multiply the sign to each term. Okay. There is nothing outside, but there is a sign outside. Here there is a plus sign. Here there is a negative sign. So we have to multiply this sign to each term which is there inside the bracket. Okay. So the first one remains the same because there is a plus sign. 2m plus mn will remain same. Then for the second one, plus into this plus will remain plus only. So plus mn plus into minus will be minus. So 3n. Then minus into this mn is having a plus sign. So minus into plus will be minus mn. Minus into this minus will be plus m. Okay. So this is why we need to put brackets here. That means if there is a negative sign outside, it will get multiplied to the signs of the terms which are there inside and the sign changes. Okay. So that is why we put brackets. Now in this we check the like terms which are there. So is there any m term? Yes, there are two m terms, 2m and m. Then mn terms, there are 3 mn terms. So this one is mn, this and this. And there is only one n term. So 2m plus m, I write together 2m plus m. Then I write the mn terms together, plus mn minus mn minus 3n. Okay. Now these two are like and these three are like terms. So now 2m plus m, there is no number here, means there is 1. So 2m plus 1m is 3m. So this becomes 3m. Then 1m plus 1, there is no number, means here there is 1. Okay. So 1mn plus 1mn is 2mn. This 2mn minus 1mn is 1, right? Like, see, it is what? 1 plus 1 minus 1. Okay. So 1 plus 1 is 2. Then 2 minus 1. So 2 minus 1 is 1. So 2 minus 1, the answer of 1 plus 1 minus 1 is 1. So we write 1 plus 1. Okay. So plus 1 mn. Then minus 3n which is left. So minus 3n. Okay. So this is our final answer. 3m plus mn minus 3n. So this is the final simplified expression of this expansion. Okay. So this was the second sum. Now we go to the third one. Okay. Now the third question is pq multiplied by p square plus 1 plus pq multiplied by 1 plus p raised to minus 2. Now here this p is raised to the power minus 2. So there's no need to think that this would be little difficult because it is having a negative sign here. The index is negative. But if you follow the laws of indices which we have studied, this negative power doesn't make any problem. Okay. So if you follow the rules, everything, the procedure is same. Only we need to consider this negative power and use the laws of indices which we have studied. Okay. So let's solve. So first, for the first expression, I need to multiply this PQ to each term which is there inside. So this is multiply PQ to each term. So PQ multiplied by P square, the first term, then plus PQ multiplied by 1. Okay. So this is the first expression. Now the second expression, PQ multiplied by 1 plus PQ multiplied by P raised to minus 2. Okay. This is the second expression. Now we multiply each term. PQ multiplied by P square. Now here you can see that, see, these are not two different terms. Okay. These are the same term. So here we cannot say that this is PQ, so it is a different term, and P square is a different term. Why? Because these are unlike terms. No. These are not terms. This whole all together is one term because it is multiplied. It is not separated by plus or minus sign. It is one term. Okay. So here you can see that there is 1 p square and 1 q. Okay. So by first law of indices, we can multiply this p and t square. Q will remain same. Q will remain as it is. Why? Because there is no other q here. But there is other p. So I write q as it is. And for p, I write this. See, there is one base p, other base p, and they are multiplied. So what do? We add their indices, right? So here I have to add the index of this 1 and this 2. So 1 plus 2 will give me 3. Okay? To make it more simple, I'll write one more step. I'll write here 1 plus 2. Okay? So this becomes q p raised to 1 plus 2. That is why, to see, here we need to use the knowledge of, we have seen how to multiply two bases, right? The laws of indices, in laws of indices we have done this multiplication and division and all. Yes, that knowledge which we have studied, we have to use it here. Okay? Now the second term, PQ multiplied by 1 will be PQ only. So I write PQ. Then we go to the second expression. PQ multiplied by 1 is PQ. Plus, this is in bracket. Now PQ multiplied by P raised to minus 2. Here there is only 1 Q. This is again like this only, but here the power of P was 2 and here the power of P is minus 2. So in the similar way, I have to solve this also. So Q, there is only 1 Q, so I write only ones, and P, there are two bases which is same. P is the same base and the indices are different. Here this index is 1 and this index is minus 2. So bases are same and they are multiplied. So what do? We add their indices, right? So I need to add 1 plus minus 2. Okay? Because we add the indices. Okay? Then this is the second step. Now we go to the third one. Q p raised to 1 plus 2 is 3 plus PQ plus PQ plus Q. And what is P raised to 1 plus minus 2? What is 1 plus minus 2? 1 plus minus 2. So what does this mean? How do we solve this? 1, this plus gets multiplied to this minus sign. So 1 multiplied by plus multiplied by minus is minus. So we get 1 minus 2. And 1 minus 2 is how much? One number is positive, other is negative. So what do? We have to subtract them. So 2 minus 1 is 1. Greater number is 2, which is having a negative sign. So the answer will also have a negative sign. So the answer is minus 1. So this index here is minus 1. Okay? 1 plus minus 2 is minus 1. So we have got the power as minus 1. Okay? Sorry, this is the power of P. Q is having 1 power and P is having minus 1. Okay? Now, we open these brackets. We remove these brackets. So QP, or we can write it as, according to the order of alphabets, P comes first and Q comes second. So it does not differ if you write QP or if you write PQ. But normally we write P is having power 3. So PQ, Q plus PQ. And here there is a plus sign. So this plus sign will get multiplied to each term. So this plus into plus will be plus. And this plus into this plus would be again plus. And this is P raised to minus 1 and Q. Okay. Now are there like terms? Are there like terms here? Yes. There is PQ term which is like PQ and this PQ. Remember this is P cube Q and this is P raised to minus 1 Q. So these two are not like terms, and there is no other like term to P cube Q and other like term to this. Only these two are like terms, so I write them together. So this first term I write it as it is, P cube Q plus 1 PQ plus 1 PQ. This is 1 here, right? 1 PQ plus 1 pq is 2 pq. So this becomes 2 pq plus p raised to minus 1 q. So this is our final answer. We cannot simplify it further. Okay, so this is the final answer. And this p here is having a negative power to it. So we can, using the laws of indices, using the the fourth law which we saw, we can take it to the denominator to remove this negative sign of the power. Okay, so we can write it like this also. P cube q plus 2pq plus q upon p. P is having a negative of 1. So when we take it down in the denominator, the negative sign goes away and p is having raised to power 1. So this is raised to power 1 and it is okay if I don't put the power. If it is 1, it is okay if I don't put the power. So you can write the answer in this way also, or you can write it in this way also. Okay, so both are correct. So this was the expansion for this. See, here the sign, the power of this p was negative, so there is no need to get frightened and think that this is very difficult or something. If you follow the normal procedure, the way we solve these examples, everything is simple. Only we need to follow the rules which are used, which we have studied. Okay, that means here we needed to use the rules of the laws of indices. Okay, so everything, if you go by rules and by the procedure, everything is simple. Okay, now the fourth sum. The fourth sum also, there are terms which are having negative powers. Like here there is the power of x is minus 3 and here the power of y is minus 3. Okay, so no need to think that it is difficult. We will solve it in a regular way we solve. So first we have to multiply this xy term to each term inside the bracket and this plus 5xy term to each term which is there inside this bracket. So I multiply xy to minus x raised to minus 3 plus xy multiplied to x. This is the first expression. Now for the second, 5xy multiplied to 3 plus 5xy multiplied to y raised to minus 3. So this is the second expression. Now further. Now here also, like we saw in this case, it is same, only the variables are different, x and y are there. So x, y multiplied by x raised to minus 3. There is one base which is same, x, powers are different, they are multiplied. So by first law, we add their indices. So 1 plus minus 3. Okay, and this y is as it is. Plus xy multiplied by x. Here also there is the same base, x, their powers are 1, 1. So the powers get added, x raised to 1 plus 1. And y, there is only one y, so we write it as it is. Then we go to this expression, 5 multiplied by 3 is 15xy. Okay, plus 5 multiplied by x, there is only one x, and y, bases are same, powers are different, we add their powers. So this is 1 plus minus 3. Okay, so what is 1 plus minus 3? 1 plus minus 3. 1 plus minus will get multiplied because there is a bracket. So 1 plus minus is minus. So 1 minus 3. What is 1 minus 3? We have to subtract. So 3 minus 2 is 3 minus 1 is 2 and greater number is 3 having a negative sign. So this is also minus. So minus 2. So what is 1 plus minus 3? Answer is minus 2. So the power of this x here will be minus 2. So x raised to minus 2 y plus x raised to 1 plus 1 is 2 y. This is the first expression. Then the second, 15xy plus 5x y raised to 1 plus minus 3. We know that 1 plus minus 3 is minus 2. So y raised to minus 2. And here you need to be careful with the powers for which the powers are. Here this power minus 2 is only for y, not for x. Okay, the power of x is 1. Here also this minus 2 is only for x, not for y. Here also this 2 is only for x, not for y. So you need to be careful when you write the powers. Okay, if you put a bracket for it, that means the power is for both. If you put a bracket here Or here if you put a bracket, that means this minus 2 will be the power of both. But no bracket, you should not put a bracket if it is for only one variable. Okay. So now I remove this brackets. So x square y plus x raised to minus 2y plus x raised to y plus, there's a plus sign, so the signs won't change. See, there's a trick. If there is a minus sign outside the bracket, then the sign of each term will change. But if there is a plus sign outside the bracket, then the signs remain the same. Like here, not here, in the previous examples which we saw, if there is a minus sign outside, then the sign of each term which is there inside will change. If there is a plus sign, then everything will remain the same. The sign of every term will remain the same. So this becomes plus 15xy plus 5xy raised to minus 2. Okay. Now check if there are like terms. Are there like terms? This is x raised to minus 2y. Is there any x raised to minus 2y term? No. This is x square y. Is there any x square y term? No. This is xy. There is no xy term, and this is xy raised to minus 2. So there are no like terms in this expression. So we cannot solve this further. So if we keep it like this only, it is okay. Why? Because we cannot simplify it further. There are no like terms which we can collect and then solve. So we keep this. Every term is different. So we keep this as it is. Or if you don't want to put this negative powers, you can take it in the denominator. So this, I can write this as y by x square. Because this x square, it is having a negative sign, the power is negative, so I take it in the denominator to make its power positive. So this becomes y by x square plus this x square y will remain as it is, plus 15xy remains as it is, plus 5x by y square. Y is having a negative power, so I took it down. So we can write the expression in this way, or we can write it in this way. Okay, both are correct. So this is the answer of this fourth expression, the expansion of given expressions. Okay. So we now go to the next sum. The fifth question now. The fifth one is p raised to minus 2 multiplied by p cube minus p raised to 4 plus p raised to minus 1 multiplied by p cube plus p square a. Okay. So by normal procedure, we go p raised to minus 2 will be multiplied to each term. So p raised to minus 2 multiplied by p cube, the first term, minus p raised to minus 2 multiplied by p raised to 4. Okay. First expression. Now second, p raised to minus 1 multiplied by p cube plus p raised to minus 1 multiplied by p square a. Okay. The second expression. Now we solve. Here this is little easy because there is only one variable. Okay. So bases are same, they are multiplied, so we add their powers. So p raised to minus 2 plus 3. Then minus p raised to minus 2 plus 4. Here also bases are same, they are multiplied, so we add their powers. Plus, here there is one more variable here, but this will remain as it is. We will see only p. So p raised to minus 1 plus 1, because this is having a plus 1 power here. So minus 1 plus 1, and q remains as it is. Plus, here again we consider the same basis, p at the same basis, they are multiplied, so we add their powers, minus 1 plus 2, and a remains same. Okay. P raised to minus 2 plus 3. What is minus 2 plus 3? Minus 2 plus 3. One is negative, other is positive. We need to subtract. So 3 minus 2 is 1. Greater number is 3, having a positive sign. So plus 1. Okay, so this is 1. Minus p raised to minus 2 plus 4. Minus 2 plus 4. One is negative, other is positive. We need to subtract. 4 minus 2 is 2. Greater number is 4. So plus 2. Okay. So this is again plus 2. Then plus p raised to minus 1 plus 1. What is minus 1 plus 1? 0. Okay. If two numbers are same and one sign is negative, other sign is positive, then their addition or subtraction is 0. Okay. So this is p raised to 0, and q is having only one. Like the power is 1, so p raised to 0 q plus p raised to minus 1 plus 2. One is negative, other is positive, so we need to subtract. 2 minus 1 is 1. Greater number is 2, positive sign, so the answer is also positive. Then A. Okay. Now p raised to 1 is p minus p square plus p raised to 0 means any number raised to 0. According to the third law of indices, we have seen any number, if it is raised to 0, then its value is 1. So 1 into q is q plus p raised to 1a means pa. Okay. Now we remove the brackets. So to remove the brackets, p minus p square. This is plus outside the bracket. Outside this bracket there is a plus sign. So the sign of the terms will remain the same. So this is plus. So plus q plus pa. Okay. Are there any similar terms here? No. This is a p term. This is a p square term. This is q term and this is pa term. So no term is like. Okay. So this is our final answer. Okay, p minus p square plus q plus pa is our final answer of this fifth expression. Now the sixth one, which is there, is little lengthy, but it is simple. It is not difficult. Even if it is having these fractions in it, 1 by 3 and 5 by 3, it is simple. We need to follow the same procedure which we have done till now for expansion of brackets. So we need to follow the same procedure and solve, and it is simple, it is not difficult. Okay, so let's see. The first step which we do is we multiply this to each term inside the bracket and this 5 by 3p to each term inside the bracket. So 1 by 3 p square multiplied by the first term p minus 1 by 3 p square multiplied by p raised to minus 1, the second term. Okay. Now we go to the second expression. 5 by 3 p multiplied by p square plus 5 by 3 p multiplied to p, the second expression. Sorry, the second term. Okay. So this is multiplication. Now we multiply 1 by 3. The constant here is 1 by 3 and here the constant is 1. So 1 by 3 multiplied by 1 is 1 by 3 only. So 1 by 3, p bases are same and are multiplied. So we add their powers. 2 plus, here the power is 1. So 2 plus 1 minus 1 by 3, p raised to, here also bases are same, powers are different and they are multiplied. So we add their powers. 2 plus minus 1. Okay, this is the first one. Then the second, 5 by 3 multiplied by 1 is 5 by 3. P raised to, here the power is 1, this is 2. So 1 plus 2 plus 5 by 3. P multiplied by P, power is 1, 1. So, and they are multiplied, so we add the powers. So 1 plus 1. Okay. Now what is 1 by 3 p raised to 2 plus 1 is 3. So 1 by 3 p cube minus 1 by 3 p raised to, what is 2 plus minus 1? 2 plus minus 1. These two signs will get multiplied. So 2 plus minus is minus 1. So what is 2 minus 1? 1. Okay. So the power of this p is 1. Then 5 by 3 p raised to 1 plus 2 is 3 plus 5 by 3 p raised to 1 plus 1 is 2. Okay. So this we have solved till here. Now we need to remove the brackets. So we remove the brackets. 1 by 3 p cube minus 1 by 3 p plus, there is a plus sign, so there will be no change in the signs. So 5 by 3 p cube plus 5 by 3 p square. Okay. So this is it. Now we see if there are any like terms. So are there any like terms? Yes, this is a p cube term and this is a p cube term. So these two are like terms. This is a p term and this is a p square term. So they are not same. So we need not add them. Now we write these like terms together. So I write 1 by 3 p cube plus 5 by 3 p cube minus 1 by 3 p plus 5 by 3 p square. Okay. Now these two are like terms, so I add them. So how do I add them? I add their constants. So 1 by 3 plus 5 by 3. So this will be 1 by 3 plus 5 by 3 p cube. Okay. Why have I written this in bracket? Because we want to add these two constants, and the variable which is there will be the same for both. Why? Because those two are like terms, so I have to only add the constants which are there. So we'll see what we get after adding these constants, and the remaining terms will remain same, minus 1 by 3 p plus 5 by 3 p square. Okay. Now we see what this addition comes out to be. So 1 by 3 plus 5 by 3. What is 1 by 3 plus 5 by 3? These are two fractions having the same denominators. So the denominators are same. We write only one denominator and we simply add the numerators. So we add 1 and 5. So 1 plus 5 is 6. So this becomes 6 by 3. Right? Now 6 by 3 we can divide. So 3 1s are 3. 3 2s are 6. So finally what do we get? 2 by 1, which is equal to 2. So this addition is 2. So I write 2 p cube minus 1 by 3 p plus 5 by 3 p square. Now we cannot further simplify it, so we keep it like this. Okay, so this is our final expression. Final expression after solving the given sum. Okay, it was easy, it was not difficult, even though there are more negative powers and even though there are fractions. If we solve it by the same procedure, following the laws, all the laws of indices and all the rules, we get correct answer. Okay, so it is not difficult, no need to worry about these negative signs and the fractions and all. And if it is a big sum, it is okay, but the procedure is same. So this was not difficult, it was easy. Okay, so this was all about exercise 2D which we did, 2D, and it was a lengthy exercise. There were many sums and I have tried to solve each and every type of sum here. We saw in our yesterday's class also that the first two questions of the exercise we have seen. So the more sums you practice of this kind, you will become more used to it, and the sums will be easy for you to solve when you practice them more. Okay, so that's it. We'll stop with this exercise for today, and the next exercise which is there is little bit more difficult than these ones. It will be a reverse of such sums. Here we have to expand the brackets, and in those sums, in the next exercise, we have to put in brackets. Okay, in the sums we need to put in brackets. So that we will do in the next class. Till then, I hope everyone has understood this. Till then, okay, take care students. Goodbye.